All right, let's pick up where we left off. In the last section, we learned how to calculate the molar mass. Now we're going to use that in problem solving. Now, this is probably a new concept for most of you. And what we're going to do is we're going to learn how to solve problems using dimensional analysis. Oftentimes in chemistry, we need to be able to relate the grams of one thing to the grams of another thing in a problem, or to the number of atoms, or to the number of molecules. So what we're going to learn to do in this section is we're going to learn to do those types of problems. And these are called molecular stoichiometry problems. Now, before we do that, we have to introduce something called the mole. Okay, and a mole is like a dozen. So let's talk about the word dozen because that's something that all of you understand. If you had a dozen eggs, how many eggs would you have? 12. If you had a dozen chickens, how many chickens would you have? 12. If you had a dozen automobiles, how many automobiles would you have? 12. Okay, but are you trying to tell me that 12 chickens weighs the same as 12 eggs or weighs the same as 12 cars? No. What you're trying to tell me is that a dozen means 12 of whatever you're talking about. Well, the word mole means the same thing. It's just a number of something. And that number happens to be 6.02 times 10 to the 23rd. And that's not exact. We could take it out to more decimal places. I choose to round to two decimal places, 3 significant figures. So that's a large number. Let's write that number out. So if I were to take that number out of scientific notation, what would I do? I'd write 602 followed by 23 zeros, right? And you're saying, no, that's not right. Because I had to move it 2 places to get it to the end of the number. So it's a 602 followed by 21 decimal place or 21 zeros. So let's write that number out. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Notice that's a very, very large number. Okay, let's look at that number and see what it is. Let's see what you know about the placeholders. This is the ones place, the tens place, and the hundreds place. These are the thousands places. The thousands, 10,000s, and 100,000s. What are these places called? The millions. Very good. Millions, 10 millions, 100 millions. What about these? The billions, trillions, quadrillions. Now, notice the prefixes. Tri, meaning 3, quad, meaning 4, 5, quintillions, and the 6, sextillions. So this number is 602 sextillion. Okay? It's a very, very, very large number. This number has a name as it's shown in your notes on page 2. This is called Avogadro's number after the chemist that developed this concept. Okay? If we go over to page 3, some interesting facts, and I'm just going to go back to the presentation. If you had, or the mass of the earth in pounds, now the earth is a pretty big thing. Notice it's only slightly larger than that. It's only 25 times larger than Avogadro's number. If you had this many M&Ms, you could cover the 48 states that connect to each other, not including Alaska and Hawaii, with a layer of M&Ms. Now, this is regular M&Ms, not peanut M&Ms, not mini M&Ms, but regular M&Ms, 52 miles deep. This is a big number. If you had that many grains of sand, it would cover all the 48 states, 3 inches deep. It's a very large number. A CD normally holds 650 megabytes of information. Now some of them hold 700 megabytes, but whenever I made this presentation, they held 650. It would take a stack of CDs that would be 580 million miles high to contain that much information, that many moles of information, or that many, a mole of bytes. Okay. By comparison, the distance to the sun is only 93 million miles. This is a very large number. Okay. The number of students we have in a class at Rome State comes to this decimal place. The number of students we have enrolled just comes to the thousands place. The number of United States citizens, there's about 330 million of us now, comes to this decimal place. The total number of people on Earth, how many people are they on Earth? Somewhere around 7 billion, only comes to this decimal place. When I wrote this presentation, the U.S. deficit was in this decimal place, the trillions. Now the deficit is $30 trillion, so we need to move that little decimal over one. The total time that has expanded since the Big Bang, since creation occurred, and we won't get into how that occurred, is only this many seconds. 14 billion years is only that many seconds. Okay? This is a very large number. Now, listen carefully. What does a mole mean? A mole is 6.02 times 10 to the 23rd molecules of something, or 6.02 times 10 to the 23rd atoms of something, or 6.02 times 10 to the 23rd formula units of something, or ions of something. It's whatever you're talking about. It's that many of them. That's the first definition. The second definition, though, is a mole is equal to 1 molar mass of a substance. That's why we use the units whenever we were calculating molar mass, the number of grams per mole. Now, we're going to use these two definitions to solve some complex chemistry problems here in a little bit. I don't want you to get lost in this chemistry problem solving. It's just the use of the dimensional analysis that we've seen before. Now, in order to help us do this, we're going to introduce something on page 5 called the mole map. Okay? So keep this page handy in your notes as we work the problems later on. You'll need this. Now, I'm going to tell you that I did not develop this. I borrowed it or stole it from somebody else, who stole it from somebody else, who stole it from somebody else. But this little map here enables us to do some complex problems. Now, watch what we're going to be able to do. In a minute, I'm going to ask you to work problems where you can convert from grams of one thing to maybe grams of another thing, or grams of one thing maybe to molecules of the same thing. So here's what we're going to say. Always when we use the mole map, we're going to start on the A side. If we're looking for something different, we're going to go to the B side. If we're not, we'll stay on the A side. You can only do conversions that have words connected by lines. So, for example, we're allowed to convert from grams of A to moles of A, but we're not allowed to convert from grams of A to grams of B because there's no line there. So what we have to do is, if we're going to go from grams of A to grams of B, notice we have to do it in several steps, just like we had to do several conversions earlier whenever we were doing our dimensional analysis to go from examples inches to miles. Okay, so we can go from grams of A to moles of A to moles of B to grams of B. Or I can go from grams of A to moles of A to moles of B to molecules of B. Now, there's three definitions that we can use. These definitions help us determine where to get the numbers. And there's only three places to get the numbers. Now, watch how simple this is. When we're converting between grams and moles, we're going to use definition 1, which says use the molar mass. When we're converting between moles and moles, we're going to count, okay? We're just going to count the indicated atoms. We'll talk about how to use the equations later on in a different subject, okay? But for now, we're just going to learn how to do what? Count the atoms. When we're going from moles to molecules, or moles to atoms, or moles to formula units, we're going to use rule 2. We're going to use rule 2. We're going to use Avogadro's number. So we're going to use three different places to get our numbers. We're either going to calculate the molar mass, we're going to count, or we're going to use Avogadro's number. Now, the next thing I'm going to tell you, which is described on the next page, on page 6. You know how when we've done dimensional analysis and I said it was very important to write the words? Now we're going to write 2 words after each number. We're going to write the units of what? So we're going to say, for example, 10 grams of sodium chloride, 14 molecules of water, okay? So we're going to write both of those words, grams, sodium chloride, molecules, water. Now, whenever we're doing dimensional analysis, you're only allowed to change one of those 2 words in a single step. If you change both of those words in a single step, you're wrong. You can never, ever, 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 except for one exception I'm going to tell you about in just a minute, change both of those words in a single dimensional analysis step. The only time you're allowed to do that is whenever you're going from molecules of A, for example, to atoms of B, when you're going across the dotted line. Then you must change both words in a single step. Okay? We're going to say you always start on the A side and you only go to the B side if it's a different substance. We're going to use those same 5 steps that we learned a long time ago with dimensional analysis to work these problems. So don't make this any harder than it is. Now listen carefully. Let's work some molecular stoichiometry problems. Now I'm going to skip back to the screen. So keep this presentation in front of you. Keep the mole map handy. It was also one of the handouts that was on the handout page, so you can print this handout, print it out and everything so that you have it available. And of course, you get to use it on all your quizzes and your homeworks and your tests and everything. So I'm going to go back to the screen and we're going to just work a few of these problems. And hopefully you'll see that this is not as difficult as it appears. Okay, so let's look at the problem on page 8. The question asks, how many moles of calcium chloride are contained in 25.0 grams of calcium chloride? Now, I'm going to put my mole map up here. So I've got grams of A to moles of A to moles of B to grams of B. And down here I have atoms of B, molecules of B, and so forth and so on. And over here I have atoms of A and molecules of A, and these are connected by a dotted line. So let's see what we know. It says, how many moles of calcium chloride? So I know that I'm looking for the moles of calcium chloride. What's the only thing that I know in this problem is that I have 25.0 grams of calcium chloride. So I'm going to always write what I know up here. Now, since I only have one piece of information, I know that I have to start with that piece of information. If you get to harder problems, they will have more than one piece of information. Now, what students oftentimes ask is, how do I know how to change from grams of calcium chloride to moles of calcium chloride? And that's where this mole map comes in. Notice where I'm at. I'm starting at grams of A. I'm starting with grams of something. And I'm changing to moles of something. Is this the same thing as this? Is CaCl2 the same thing as CaCl2? Yes. So I'm looking for moles of CaCl2. Now I ask myself, can I do that in a single step? And I can, because why? What I'm starting with and what I'm looking for are connected by a line. So what does dimensional analysis say to do? What word has to go on the bottom here? The grams of CaCl2 has to go on the bottom so that it cancels. And I can put the moles of CaCl2 on the top. Now, if I've done this correctly, the words cancel and I'm left with the word that I'm looking for. Okay, so does everybody see how I did that? All I have to do now is find the numbers. Look at your handout. Whenever I'm converting between grams and moles, which definition do I use? I use the definition that says use molar mass. Okay. Now, if I calculate the molar mass of this compound, I find the molar mass, and we learned how to do that, so I'm not going to do that again, is 110.983. Okay. Now, if that's the molar mass, though, my question is, what's the units? The units are, remember, always grams per mole. So notice, if that's the units of molar mass, notice the 110 is written beside the word grams. So it has to be on the bottom in my dimensional analysis problem. And 1 goes on the top. So whenever you're trying to decide whether the number goes on top or bottom, you're using the same dimensional analysis rules you learned before. The 110.983 grams of CaCl2 per 1 mole of CaCl2. Notice if you say it out loud, knowing the units are grams per mole, you can't get the words upside down. So the answer would be 0.225 moles of CaCl2. Don't make this any harder than that. Okay, the next problem we're going to look at gets a little bit harder, but not much harder. Okay. Let's look at another problem. You're going to say, oh, I thought you said it wasn't going to get much harder. It really isn't. Let's look at another problem. Okay. Going over to page 9. Notice it said, how many atoms of chlorine are contained in 8.00 grams of BaClO3 taken twice? So again, we're starting at grams of one thing. Now read the problem. What am I looking for? Atoms of something else. So I'm starting with 8.00 grams of BaClO3 taken twice. And what am I looking for over here? Atoms of chlorine. Now, if I look at this problem, I'm going from grams to atoms. The question is, am I going to this atoms or am I going to that atoms? Is BaClO3 taken twice the same thing as Cl? No. So that tells me I'm going to atoms of something different. I'm going to atoms of B. So can I do that in a single step? No. What do I have to do? I have to change from grams of A to moles of A to moles of B to atoms of B. So what I always do is I always write my words down and then come back and get my numbers. So we know from what we know about dimensional analysis that grams of BaClO3 taken twice has to go on the bottom so that it cancels. Now, according to my mole map, what do I change that to? Moles of the same thing. Okay. And how do I know it's the same thing? Because we can only change one word at a time, and notice both of these are A's. But we're not finished with the problem because, again, we're looking for atoms of chlorine. So in the next problem, I put moles, and I'll write it underneath it to save me some room, moles of BaClO3 on the bottom so that it cancels. And what does it tell me to do in the next step? Change to moles of what I'm looking for. So I'm going to change to moles of the chlorine. Okay, the B is what I'm looking for, the chlorine. I'm still not finished because now I have to go from moles of B to atoms of B. So I'm going to go from moles of chlorine to atoms of chlorine. Now notice I've got my words finished. All I have to do now is put my numbers in. And remember, there's only 3 places to get the numbers: the molar mass, count, or use Avogadro's number. So in the first step, what am I changing from and what am I changing to? Grams to moles. Notice the molar mass was given to you in the problem, and notice it was 304.229 grams per mole. Now, if you would have calculated this using a different periodic table, you may have gotten a slightly different molar mass. Don't worry about that. Okay, I use different periodic tables whenever I was working the answer keys to these problems, so I may have got a slightly different number. So notice that's where we got those numbers. Now, where do we get the numbers to go from moles to moles? Our definition says we count. So we count what? The chlorines, because that's what we're looking for. So how many chlorines are in a BaClO3 taken twice? Notice there are 2 chlorines in one of these. We're just counting. Now there's some oxygens in there and some bariums also, but we don't care because we're only asking the question about the chlorines. The next one, how do I go from moles to atoms? If you look at your mole map, that's where it says use Avogadro's number. And remember, Avogadro's number is always that many things, 6.02 times 10 to the 23rd atoms per 1 mole. Okay, so notice the molar mass is always that many grams per 1 mole. The Avogadro's numbers are that many atoms or molecules per 1 mole. And to go from moles to moles, we just simply count. And the answer is 3.17 times 10 to the 22nd atoms per mole, or atoms of chlorine, rather. Remember, when you plug in numbers in scientific notation, you don't hit the times 10 key on most calculators. you've got a double E key. So if you're getting off by power or something, you're plugging it into your calculator wrong. Okay, so that's all there is to this. Let's look at another problem on page 10 that helps illustrate this. Okay. So when you go to page 10, it says how many grams of nitrogen. So we're looking for how many grams of nitrogen are in 7.00 moles of N2O2. Now let's see where we're starting and where we're ending on our mole map in this problem. Notice we're starting with moles of A and we're ending with grams. Is it grams of A or grams of B? Notice since this N2O2 is different from the N, we're looking for grams of B. Now notice we're already at moles. We know that moles of the N2O2 has to go on the bottom so that it cancels. Okay. But we don't have to change the grams because notice what the first step says to do. Change to the moles of N. The moles of what we're looking for. Then in the second dimensional analysis step, we change from the moles of N to the grams of N. Notice moles to moles, and then moles of B to grams of B. Now we just put in our numbers. And again, there's only 3 places we can get our numbers. Here we're changing from moles to moles. What does our handout say to do? We count. Okay. So how many N's are in an N2O2? There are 2 of them. And notice if I say it out loud, 2 N's per 1 N2O2. I can't get my numbers upside down. Here we're changing from grams to moles. And the molar mass of nitrogen is 14.01 grams per mole. Okay. Notice how I knew it was just nitrogen and not the N2O2 because look at what's in my conversion factor. When I punch it in on my calculator, I get 196 grams of nitrogen. So don't make this out to be any harder than it is. Now, the next problem on page 11 is going to illustrate that there is 2 different ways to do the next problem. Which way is best? The one that you understand. Let's look at the problem. It says, and I'm going to have to write this a little bit up here to the top and down here because I need to write it twice. The question says, how many atoms of zinc are contained in 7.3 times 10 to the 22nd, 7.3 times 10 to the 22nd molecules of ZN3P2, zinc phosphide. Now, where am I starting at on my mole map? I'm starting at molecules of A. And where am I trying to get to? Atoms of something different, atoms of B. So how would you do that problem? Could I go from atoms to moles, from molecules to moles to atoms? I could, but since they're connected by a line, I should be able to do this in one step. So if I do that, then molecules of zinc phosphide goes on the bottom. Whoops, molecules, not moles. Don't abbreviate any of these words that start with M. It just causes you to get confused. Molecules of zinc phosphide. And notice I should be able to go to atoms of zinc. And the rule says when you're going from here to here, we use definition that says, definition 3 that just says count. Okay, so what am I going to do? How many zincs are in one of these? 3 to 1. And when I punch it in on my calculator, I get 2.2 times 10 to the 23rd. Now, don't make this any harder than it is. It's just a little bit of dimensional analysis, okay? Now, I could have went, and I want to do this the other way, 7.3 times 10 to the 22nd molecules of the zinc phosphide, and I'm looking for atoms of zinc. I could have done the problem this way. I could have went from molecules to moles. So let's do the problem that way. So notice I'm going to go from molecules, zinc phosphide, to moles of zinc phosphide. Where do I get those numbers? We'll get them in a minute. Then I can go from moles of zinc phosphide to moles of zinc. Again, notice I'm canceling my units as I go. Then I can go from moles of zinc to atoms of zinc. Where do I get the numbers to go from molecules to moles? Again, that's Avogadro's number. Remember, there's only 3 places to get these numbers. 6.02 times 10 to the 23rd molecules per mole. Where do I get the numbers to go from moles to moles? I count 3 atoms of zinc, or 3 moles of zinc per 1 mole of zinc phosphide. How do I get the numbers to go from moles to atoms? 6.02 times 10 to the 23rd atoms per 1 mole. And notice we get the same answer. Okay, so which way's best? If you like going the long way, you can, or you can use the shortcut. Whichever one works best for you. Sometimes the shortcut works really nicely. So go to the problem on page 12. Notice the question says the total atoms. So we know that we have 12 molecules of zinc carbonate. And we want to know how many atoms total. Okay, so notice what I can do. Put 1 molecule on the bottom. Now notice it's not asking for how many atoms of zinc, how many atoms of carbon, or how many atoms of oxygen. It's asking for the total atoms. So notice there are 5 atoms total per 1 molecule. There's 1 zinc, 1 carbon, and 3 oxygens. And notice the answer is very easily determined to give you 60. Okay? Very, very straightforward concept. Students struggle with this dimensional analysis. Okay? All problem solving in chemistry builds upon this type of concept using this mole map. Practice this in the homework sets. If you have questions, feel free to ask me. Don't cheat and just write down the numbers. Anybody can punch it into the calculator. The hard part is figuring out whether the numbers go on top or bottom. And remember, if you say it out loud as you write it, you can't get it upside down. If the molar mass is 22 grams per mole, notice the 22 has to go beside the word grams. So practice this. And again, if you have any questions, please let me know.